Assalamualaikum. This is question. This is Adexel International IAS unit number 1, October number 2022 past paper, and today I'm going to give you about details solutions of question number 18. It's a tricky question, so here we go. Question number 18 is basically related to a railway engine is pushing a truck along a horizontal rail at a constant velocity. This is the most important thing you can say in the entire question, that this is moving with a constant velocity. The engine exerts a forward force of this is basically the forward force. Let's say, let me call it F1, and on the truck, and the engine also exerts a net backward force of 1.5 into 10 raised power 5 Newton on the trail. The question is complete a free body diagram or free body force diagram to show all the forces acting on the engine. Okay, so there are two forces mentioned basically, and these two forces are they are forward force, and one of the force is the net backward force. So forward force and net backward force means that these forces are there. So I have mentioned this is the forward force. Forward force is 1.2 into 10 raised power 5 Newton, and the backward force is 1.5 into 10 raised power 5 Newton. So these two forces are basically mentioned, but there is a third force as well, and that third force, because the object is moving at a constant velocity, that is why the difference between these two forces is not zero, but there is another force which is equal to the difference between these two forces. So let me call it force F, forward force. So that will be basically 1.5 minus 1.2 into 10 raised power 5. So it is 0.3 into 10 raised power 5 Newton. So this is 0.3 Newton into 10 raised power 5 Newton force. This is basically one of the backward forces. So if we consider that the complete force or the free body diagram, that free body diagram will be like weight force, normal force, yes, that is, and one of the forces you have to draw here, as I told you, that is the forward force, and you have to mention that 1.2 Newton force. The second force you have to mention in the forward direction, that is that is 0.3 Newton force, what I have just considered as a difference of these two, and as a sum of these two forces there is a backward force which is basically equal to 1.5. So here is the solution of these two. You can say, you can draw this over this one. So you will mention these two forces, and if you are going to figure them out, this is your 1.5 into 10 raised power 5 Newton. This blue is 1.2 into 10 raised power 5 Newton, and this black one is 0.3 into 10 raised power 5 Newton. Hopefully this diagram, free body diagram, will be clear to you. That is a tricky question, and in the next part it is said the student suggests that the weight and the normal reaction force are the Newton's third law pair of the forces. So you are supposed to deduce that. Explain why the student's suggestion is not correct. Your answer should be include the reference of the features of Newton's third law of the pair of the forces. So according to Newton's third law of motion, there are several points which are very important to notice, and those points are that if we have Newton's third law, according to Newton's third law of motion, both the forces should be equal and opposite. Okay, that is why first of all we will have some tests. Okay, Newton's third law. have some tests, and these tests are very easy to perform, but mainly what I would request you, that if you remember these three main tests, that both the forces are equal in magnitude. Yes, they are. Both forces are equal. Secondly, they are opposite in direction. Yes, they are opposite in direction. There is third and fourth test which is not fulfilled or which is not qualified here, and that is that the forces should be of the same type. The forces which are not of same type, okay, these forces are not of same type, so that is why this is not Newton's third law. And fourth test, that the both forces should be on two different bodies, not on the same body. This is one of the most important tests, that both forces must be at two different bodies, okay. So that is why you can say that this test number 4 and test number 5, that is not qualified. So when these tests are not qualified, simply this is they are not following Newton's third law of motion, or you can simply say that Newton's third law of motion is not applicable here, okay. So this is basically one of the main important thing, that yes, these all are the points. For example, I can further explain this question to you, and the further explanation for this question is that, for example, if you increase the weight force, right, but at a certain angle, right, so here, for example, the train is at this angle, let's say, so its weight is, suppose this is its weight, so this is normal reaction force, so this normal reaction force must be equal to weight, which is not, yani now normal reaction force is not equal to weight, rather it is equals to weights cos theta. So that means that normal reaction force is not a reaction force of weight. Remember this thing, okay, reaction of weight force.